Hello students, this video is to prepare you for quiz 7.04 exponential growth and decay. Please copy all of the questions, the notes, and the answers that I present in this video. Pause it as needed. The first question is to analyze the graphs below and select those that could model exponential in an exponential equation. Select all that apply. So what you need to know about this question is that exponential graphs all have this kind of a shape. Okay, they all curve. Some take longer to curve and some curve more quickly, but they always curve in this direction. Okay, so this first picture is an answer. So you would want to select it. Okay, this is an exponential graph. What you want to stay away from is any graphs that are not curved like this. For example, a straight line. That's not exponential. No matter what direction it's going in. If it's straight, it's not exponential. It needs to curve. Also, U-shapes are not exponential. Okay? So all of these are not exponential. All right, let's move on to the next question. Question number 2. A bank deposit that earns interest annually is given by the function f of x equals 3,000 times 1.05 to the x power. What was the initial deposit? In order to understand this question, you need to know the basic formula for exponential equations. And here it is. Most of the time there's two numbers being multiplied. This first number is like your y-intercept. It's your starting point. And this number over here is like your interest, or how much it's growing by, how much it's, if it's doubling, it'll be a 2 right there. If it's tripling, it'll be a 3 right there. It's your growth rate. And your x in problems like this is usually your time, so how many years have passed by, etc. So that's usually your time. Alright, so just by knowing this, you really don't have to do any math. You just have to recognize that they want the initial deposit. That means how much did you start off with? What was your starting amount of money? And that's the number in front. That's the starting amount. So if you look at the equation, that's the 3,000 that's right here in front. That's the initial amount. So the correct answer would be the third one. Question number 3. A deposit of $2,000 earns 3.5 interest annually. Which function models this situation? Again, we're going to use the formula that I talked about earlier. And your initial amount is 2,000. So the 2,000 will go right here. This is where you always put the initial amount. And then in parentheses, we will put the rate, the interest rate. But it says here that it's 3.5% interest annually. What you need to realize is that it's going to grow by 3.5%. So it's like you're taking the amount you have, and it's going to be 1 plus the rate, because it's 100% of the money you have, plus the rate of 3.5%. So think of it as you're going to have 100% of your money plus a little bit more. And how do you make 3.5% into a decimal? Hopefully you remember that you move the decimal twice. So I will move it twice to the left. And the answer then becomes that 3.5% is really 0.035. If I add up 1 plus 0.035, just think about adding it like if it was money. What's $1 plus 0.035? $1 plus 3 cents, or 3/5 of a cent. So it's just you just put it all together, and the answer becomes 1.035. And this is our growth rate. Okay, so our growth rate is 1.035. So I'm going to plug that in up here. So here is our final answer. F of x, I'm sorry I put y, but it should be f of x. F of x equals 2,000 times 1.035 to the x power. And the answer that has that is the last one. Question number 4. A $25,000 car depreciates at 16% each year. In the exponential model of the form y equals a times b to the x, which value would represent the value of b in the function? In this situation, usually it's the growth rate, but in this case it's depreciating. The car is losing value. So that means it's a decay model. And instead of doing 1 plus the rate, it's 1 minus the rate. It's decreasing. So it's going to be less than 1. So again, how do you make 16% into a decimal? You put the decimal at the end, and then you move it twice. So 1, 2. So it's really 0.16. And then you plug it into this model here, and it's going to be 1 minus 0.16 because it's decreasing by 16% per year. And that equals 0.84, which would be the third answer here. Question number 5. What is the percent decrease modeled in the function? So really what they're asking you here is one takeaway. What mystery amount would give you the 0.85 that you see present here? And it's 0.15. So that would translate into 15%. So that would be the first answer choice as the answer. Question number 6. The amount of money in a bank account with an initial balance of $15,000 earns 3% per year. In the exponential model of the form y equals a times b to the x, which value would represent the value of b in the function? Remember, b is your growth rate. So it's 1 plus the interest rate. The interest rate is 3%, but as a decimal, it's 0.03. So what's 1 plus 0.03? Just put it together. It's like $1 plus 3 cents. So the answer is 1.03, which would be the last answer choice here. Question number 7. A $7,000 motorcycle depreciates. That means it goes down in value at 10% each year. Which value would represent the base of the exponential function that models this situation? Again, the b, or the base, would be 1 minus the r. Minus because it depreciates. So it depreciates at 10% each year. 10% as a decimal. You move the decimal twice, and it's 0.10. 1 take away 0.10 is simply 0.90. That would be answer choice number 1. Last question. Which of the following cannot be modeled by an exponential function? The first one says the amount of bagels sold in the morning if the store was selling at a rate of 6 bagels per hour. This is not an exponential function because the rate is constant. It's always 6 bagels per hour. That's going to be a linear function. 6 is like the slope, 6 over 1. So don't pick that one. The second one says the amount of money in a savings account that earns 3% interest annually. This is exponential because it's gaining at 3% annually. So this is an example of exponential growth. A loan that changes 2.5 interest rate monthly, that is also exponential growth. And then the changes in temperature of a cup of ice after boiling water is poured into it. And we're going to leave that as not being exponential because it probably cools off at a fairly linear rate. So that's it. Please take the quiz now, turn in these notes, and together you will get 4 points extra on your quiz. You might not need it, but I can still give you the 4 points even if you pass it and do well. Thank you for watching.